Hello everyone, this is Keenan again for our Rhino workshop series. So we're going to, after that introduction to Rhino interface and basic sort of what is Rhino, how do we move around it, we're going to start creating some geometry now. So this is where the fun really starts to begin. And this is starting in the PDF guide right around topic number 5, moving objects in Rhino. So we talked all about this sort of general stuff over on our main tour. For this stuff, we're going to focus on, for this next part, we're going to focus on this little cluster of objects. And this is another great time to use our zoom selected command. So that's, again, just selecting some object we want to focus on, typing in ZS, and then pressing enter. One specific thing I wanted to highlight. To enter a command, obviously enter is working fine, but the space bar also acts as enter. So if I typed in ZS and then space bar, you'll just have to trust me that I'm pressing space bar. It will also act as like that enter option. Another way, there's 3 ways. Another way is to type in ZS and then you can right click. Oops, excuse me. Without panning or orbiting, just right click. There we go. And that also will create that or activate that command. So this can be helpful because I often will just have one, my mouse hand doing its mouse thing, and then I'll usually just type commands with my left hand so that I can keep my left hand just, not having to go back and forth so much. So anyway, just something to think about. If that workflow is helpful for you, spacebar, enter, right click, all do the same thing in Rhino. Okay, so zoom selected, and let's just kind of get reoriented to this little cluster. Alrighty, so I think we are going to talk about how to move objects in Rhino really quickly. Well, we're going to talk for a little while, but how to move quickly. Okay, cool. So several ways you could do that. If the gumball is not on, we talked about that earlier. So by selecting an object, you should see this green, red, and blue arrows, and then a cluster of other options. So if that is not showing up, make sure it is under this little gumball selection toggle. But even with it out selected on, you can click and left drag, like left click and drag an object, and it'll move it around. It's not going to move it very precisely, but you can move it around. And you'll notice it's also snapping to my ortho directions. So if you really want to be loosey-goosey, you can uncheck ortho down here. And now I can move it wherever I want in Rhino. I rarely do it this way, but it's an option. I will re-enable ortho, and I'm going to turn the gumball back on because we're going to talk about how to move with the gumball. And we're actually going to cover topic 7, editing with the gumball, in this sort of intro here. Okay, so our gumball. Let's look at this cube for this section. The gumball, and I honestly don't know where the name comes from. Red, green, blue. I guess gumball colors. Who knows? The gumball in Rhino is going to be one of your best friends in terms of how to move or edit objects pretty quickly. It gives you this 3 arrows for the 3 different axes. Red is X, right? If I go this way, it might make a little more sense. X this way, green, up and down, or, well, relatively up and down. Blue is our real up and down, right? So that's our Z axis. And green is Y. So you can move an object in 3D space pretty precisely, at least one axis at a time, by just clicking on the arrow. And so this is where I wanted to double check that people were, I was being clear and that people were understanding what I was trying to get at. So if you hover your left mouse over there, you'll see that axes go kind of dark. And that will define whatever movement you're going to make on that axis. So that's just a point to make. If you left click what in the center, in this sort of where this gray dot is, you'll see well, hovering over it, all the axes will go black. So this will allow you then to move it in any direction, and it's still snapping to my ortho, right? But that's one way to like make sure if you want to be moving in all directions, you could go to the center. But you know, I usually just go one axis at a time. Another way is, and this will depend on your camera position. So let's go an orbit towards the top. You'll see these sort of green and red grid lines show up. I can click and drag, and now that's going to be moving it in both the X and Y at the same time, but it's not going in any Z direction, right? So it's just allowing me to move in X, Y. Similarly, if you orbit to the side, you can see this blue and green grid. That will allow me to go in the Z and Y directions, but not any X. So another type is going to the front here. If you wanted to move in X and Z, but not Y, you get your red and blue grid. So that can be helpful. You know, you can think about those sort of 3 different ways of moving with those grids, or on a single axis at a time if you just want to do that. Okay, great. So another way of editing an object precisely, you can also type in an exact distance. So instead of clicking and dragging on that arrow, let's just single click on the green. Now this little pop-up shows up, and this will allow me to enter an exact distance. So our units in this model are inches, so I'll just type in 10 for 10 inches, and then I'll press enter. And that has now moved it 10 inches in the Y axis relative to where we started. So that's a super handy way. Now Rhino's pretty smart. It'll remember that last increment that you entered. It's like, oh, do you want to move that same distance? If you wanted to go back 10 inches, you would just put a minus sign in before that, whatever increment. So I'll do minus 10 and then enter. That's how we can go in the negative Y direction. And these will always be relative to where the arrow's direction is pointing. So the arrow is indicating the positive direction. If you're ever getting lost, that's just one way to remember, right? So same in the X-axis. So in this case, maybe I want to go, double check that. Okay, not double click. Single click on the red arrow. And let's say we want to go 30 units this time. 30, enter. So I've got 30 inches from my last point. Pretty easy, right? So there are a few other things we can do with the gumball. Now we're kind of floating all crazy in space. That's all fine, though. You'll notice these sort of arcs. They've got like the red arc, the blue arc, and the green arc. These allow you to rotate this object in those axes. So it's a little hard to tell with this cube. So let's go over to our cone, because if we rotate a cube, you're not going to notice much difference. But with a cone, you will. So let's go ahead and we're going to actually drag this over just so we get a little breathing room. Going to zoom selected. How about that? ZS, enter, or spacebar. So now, for instance, let's say we wanted to rotate this cone about the x-axis. We would hover our mouse over that red arc, clicking and dragging. Now you'll see this sort of series of arrows. And if I move my mouse around this circle, it allows me to rotate around the x-axis, that red arrow. So you can think of like if it's like a globe, right? If our globe's axis is this red arrow, that's the one I'm rotating around, right? Now, if you want to toggle that ortho snap off, you can either do it like globally just by unchecking the ortho, and then we can rotate at any increment, right? It's not snapping to 90 degrees. I can go at any sort of freeform increment I want. So we could do it that way, or I'm just going to undo my rotation, toggle ortho back on. Now, so another way to be out of ortho mode in a more sort of fast way, I suppose. So I'll still left click and start moving this around. However, if I hold shift now, it will allow me to infinitely rotate that in the same way. It just sort of bypasses ortho. You can see if I let go of shift, ortho is re-enabled, and then it snaps to my 90-degree increments. So this is generally how I model. I keep ortho on by default because I usually want things to be parallel. And then if I want to, I can hold shift and get in an incremental sort of movement. So it's just it's a little bit more precise to have that on by default and then be really specific about when you're turning ortho off. That's my preferred method. So we can do that in any of these axes, right? So we can do it in the green axis, same. And then we can do it in the blue. Now, you'll notice since we've rotated this in this case in the in the Y axis, the green axis, my gumball has reoriented, and now my Z axis is no longer up and down in the world. So that's totally fine. By default, if you've just done this rotation, it will still be relative to its starting point. However, if I deselect this object by either clicking off to the side or pressing the escape button and reselect it, now you'll notice that green axis is where it should be and the blue axis is where it should be. So that gumball resets to the global or the world coordinates every time you select an object, unless you toggle on a more custom way to do that. But for now, we're just gonna note that, right? So if you're wondering, like, oh wow, why did my why did my blue arrow suddenly go back to the starting point? It resets every time you select that object because by default it aligns to the world XYZ axes. The gumball aligns to the world XYZ axis. Okay, cool. So you'll notice, like, yeah, you can do this in any orientation, right? Cool. All right, so those are those arcs for rotation. You'll notice there are these other squares that kind of come opposite of the arrow, and there's this dashed line and then a square. These are the scale handles, and they allow you to scale an object along that axis. And I find that the cone is a little confusing to show this. So let's go back to our cube. We're going to zoom select. Alrighty, so for instance, let's say we want to scale this only in the Y axis, the green axis. I'm going to click and drag over this square scale handle, and you'll notice I'll be able to scale that in one direction. So, I can create a longer rectangle, can go thinner along that, but it's not messing with the other dimensions, just that one axis. Pretty handy. Same with the X axis, the red, I can scale in that direction. Same with Z. So this is a way you can pretty quickly change the scale of an object relative to its center point. That's the default gumball location, is the object center point. So you can kind of see it's floating in there. If you want to scale an object uniformly, you can hold shift and then click and drag any of these scale handles, and it will scale that object uniformly from the center of the object. So that's just some good, useful information, I think. I use this a lot for quickly kind of bringing in an object. If you want to be precise with this editing of a scale, you can, I'm just going to undo a few steps so we get back to our cube. So for instance, if you just wanted to double the size of this cube, you can select that cube, and then let's say we want to double it just in the Y axis for now. I'm going to click that square, and now if you think as 1.0 as being the current size of this cube, 1.0. Anything above 1 is going to be increasing the scale along this axis. Anything below 1 will be decreasing it. So if I wanted to double it, I would just say 2, right? It would be twice as long in that direction. And now it's pretty much doubled it in that. If you wanted to, now since we have changed this, right? Like if I did 0.5, that would be half of my current z axes, and it would be back to my square. If instead I wanted to make this like, perhaps 0.25 of what my current y-axis is. I would not put a minus, rather, I would put 0.25. And that would be a quarter or 25% of my 1 unit starting point. So it doesn't really matter, like there's no units in the scale feature. It's just relative to whatever the current size is. So now, I could do, again, I'd do or in this case, let's do 0.5. And that would just, reduce that by 0.5. It's always relative to its current dimensions. So just keep that in mind. Okay, great. I guess I should have also mentioned with the gumball, if you wanted to rotate at a specific degrees, you can do the same idea. You can click that axis, left click, and then it brings up this little box. So you can enter, in this case, a degrees out of 360 degrees, right, that make up a circle. So you could say, oh, I want to rotate this 45 degrees. And you see these little blue arrows. These are indicating the direction of rotation. So I'll just say 45 degrees, and it's going to rotate it, in this case, counterclockwise, right? And it would rotate it 45 degrees. If I wanted to rotate it backwards, in this case, counterclockwise, just put in a minus 45 degrees. And I get back to that starting point. So those are the ways that you can either freeform move, more precisely enter a movement distance, freeform rotate, either with your ortho snaps or by holding shift to get any degrees of rotation. Or you can be more precise by clicking and entering. You can do this in any of those directions, right? And then also by scaling, either like very loosey-goosey with it, or scaling it uniformly by holding shift and clicking on any of these. You can also hold shift, I believe, and press 0.25. Yeah, that will work also, is to scale it uniformly. You just hold shift, click any of the axes, and then if you want to scale it uniformly, you can, whoops, it's already at 1:1. Let's say we want to double its current size uniformly. I held shift, click, enter 2, and it scales it up by 2 uniformly. So those are all kinds of ways that you can use the gumball to edit. All right, now there's another feature with gumball that I really use a lot. It's using the gumball to make quick copies of an object. So say I wanted to create multiple copies of this sort of strange rectangle cube. I'm going to start by clicking on any axes, really. Let's just use the green Y axis for now. I'm going to click and drag and move it. And without letting go yet, I'm going to quickly tap the Alt button, or in Mac, it's the Option key. So quickly tapping Alt or Option, and it's a very quick tap. You'll see this little plus symbol come over my circle. That means that if I release my mouse button, it will make a copy of that object. So again, on any of the axes, let's do the blue one this time for Z, click, drag, without letting go yet, I'm going to tap Alt or Option very quickly, and you can toggle this on and off just by tapping Alt or Option. And then let go. Wherever you let go, that copy will be created. And you can do this with multiple objects. So say you wanted to create a bunch of these all at once, right? This is the joys of logarithmic growth, right? Exponential growth. That's how you would create a quick copy of an object, just using the gumball. Very cool. And again, any of the axes will work. So a great little shortcut there. Okay, so, well, got so many of these little cubes. Well, they're not cubes anymore. Okay, I'm just going to delete those. You can select all sorts of objects by quickly making a big window over that. We'll get into window selection in a little bit. Alrighty, so that's using the gumball to edit geometry fairly quickly and precisely. We're going to shift gears now. So we've just been messing with existing geometry, but we're going to go ahead and create some of our own geometry now. First of all, let's go over to our layers tab, and we're going to change our current layer. And, you know, just in keeping with good layer management, we'll go ahead and create some boxes next. So let's make our box layer the current layer. And with that current layer selected, you'll see the check mark, and you'll also see down here our little box layer is now displaying our current layer. All right, so a few different ways we can make this box, right? First way is to go to our toolbar on the left-hand side here and go to our box command. That's just our top one. And again, remember, if you want to see the sub commands that live under this main one, right-click and hold. You'll see all these other ones. So we can click the box command, and right away now the command line will start stepping us through this command. The first corner of the base. So I can click anywhere I want on this plane, and that will be my first corner. Now the second corner, or now it's saying I can enter a length. So for now we'll just do a free form, and maybe we'll do a rectangle kind of shape. So I'm going to click right there, left click, I'll zoom in a little. And now it's asking for the height. The command line's prompting me. So whenever you're stepping through a command, always make a habit of checking what it's prompting you to do here. There can be various options that you can select. But for now, we'll just say an arbitrary height. So we'll just make a box here. Cool. So that's one way, just using the toolbar over here. But I often find that some of this is easier using the command line. So handily enough, the box command is simple enough as typing box. And you'll notice sometimes there'll be a lot of other commands that share that keyword, right? So box, there's box edit, there's cell box, select box, a bunch of other things. It can be handy to find related commands, but usually the most basic type of that command will be the first one. And you don't generally need to select a different one unless that first option is not the command that you're looking for. But in this case, I'm just going to type in box. I'm not going to bother selecting it. I'll just press enter because it'll choose that top one. And it's now asking me to do the same thing. You can click and drag a box. Great. Boxing. We're boxing today. All right. Oh, goodness. Okay. So, for instance, another type of way of creating this box is typing in box. Now, without clicking, you'll note that there are several sub options in these parentheses. So these are just different ways that I can create this first corner. The default is by specifying one of the corners, but maybe you want to create it from a center point. So you can click center. Now, center of the base is what I'll be defining. So this way, you'll notice instead of going from one corner to the other, now I'm going from the center out towards one of those other corners. And so I'll left click and just kind of step through that. So there's just multiple ways, and each command will have its own options within that. And just take a look at those parentheses to see what those options are. Sometimes they're very simple, sometimes there's none at all, sometimes there's a lot of different ones. So just give that a look. Okay, cool. So we've made some boxes. This has been pretty cool. Now these are solid objects, right? These, if we select one of them and go to our properties tab, you'll see this closed extrusion. And so these are closed, they're solid. There's no open surfaces. It's a nice thing about using the box command. So that's great. Okay, cool. So if we wanted to create some cones, we could also do that. Let's go ahead and make the cone. And now I'm not going to worry yet about changing my layer to a different one. We'll just make a generic cone for now. The same idea, base of cone, and our parentheses in this case, I'm not really concerned with any of those. So we'll just create our center point here. And now it's asking for the radius. So instead of like maybe defining an arbitrary radius, we could type in this case, a specific distance that we want our radius to be. So maybe we want our circle to have a diameter of 20. So our radius now would be 10. So I'd type in 10 and I'd press enter to set that. And now it's stepping me through that next point. So now it's saying, okay, the end of cone. And this is, again, relative to that starting point. So I could go up an arbitrary distance and left click to create that. Or if I wanted to be more precise, maybe I need a cone that's like 40 inches up from that base point. So that's another way that you can create those geometries. We can do the same thing with the box, right? We can left click the box command. In this case, I'll just start kind of arbitrarily here. And instead of clicking my next point, I can look at my command line and it'll say other corner of base or length. So in this case, your box is always going to be X length and Y width. So you can think of it like if you remember geometry, right, from high school, it's always an XY coordinate. So in a command, it's always the X point first and then the Y as your second length. So in this case, I'll type in, I don't know, maybe like 50. So that's see how it's going in my X axes. And if you're lost, you can see the red line is our X axis, right? So it's gone 50 inches from my starting point when I typed in 50 and pressed enter. So now maybe I want to do like 30 units in the Y. I can type in 30. Oh, excuse me, I forgot to press enter on my 50. You'll see that you have to press enter after entering in your length. So now it's prompting me for the width. There we go. So now I can do 30 for my Y units. And let's say, I don't know, we can do 10 units high. So that's a way to precisely create a box with those given dimensions. So different ways, right? So many different ways. You can be free form with it like we were earlier. You can be precise with it like these two examples. Okay, so you'll notice that I've created the cone layer on my box, my cone object on the box layer. There's a few different ways that we can change objects to different layers. What I prefer is the fastest way. So select that object. Now you'll see down here, it will show whatever object that layer is assigned. So right here, it's sample objects on the box layer. So if you click this, you can quickly change it to any of your project layers. So in this case, I'll go to the cone layer and just left click, and it's boom, done. You'll see sometimes people want to go to your layers tab, and for instance, if I wanted to select all these boxes we made earlier, there's another way you can do this. It's the longer way, but say just for demonstration, I'll change these to the cone layer. You can right-click the layer that you want to change it to. So the cone layer in this case, right-click cone. Now you go to the drop-down menu that comes up all the way down here, change object layer. So you can do it that way. It's super long and I would not recommend it, but it's an option, right? It's just way easier to go that, boom, boom, and boom. So much easier. Okay, so there's another way. There's so many ways, but if you have a lot, this could be one way to do it. It's to use the command line itself. So I would select the objects I want to change, and then Rhino's fairly intuitive with your commands. So you can think of like, what do I want to do? Okay, I want to change an object layer. So I'm going to type in change, and here it's already autofilling change layer. That's what I want. So I'm going to press enter. Now it'll pop up with all these layers of my project, and I could pick any of these that I want. And then I would just say, okay, that's another way. So there's a lot of different ways, right? Some days it's just whatever workflow makes sense. For me, 99% of the time I'm using this this layer drop-down menu to change things to a box layer, for example. Great. Okay, so those are some basic like volumetric ways to create geometry. But let's look at how to create some basic curves. And remember, in Rhino, curves can refer to any straight line, any series of straight lines, arcs, or more like what you would think of curves as being like curvilinear. So we've been creating this stuff in our perspective for the most part. I think that's great for when you're creating volumes. However, if you're starting with lines, I would recommend the top view for the most part to create our geometry. So I'm going to double click perspective, get back to my 4 default views, and then I'll double click into the top view. Now, right off the bat, I think this is a great time to talk about construction planes. So this grid that we've been kind of seeing earlier, this is a construction plane, and that's essentially a flat 2D plane that extends infinitely. The grid just sort of shows you where you are in that, but it goes on forever. And it is a flat plane that is used to create 2D lines. And the top viewport, or I'll just go back to our 4 views for a second. Our top viewport and our perspective viewport share the same construction plane. So I think for this little demo, let's keep both of these viewports active. I'm just I'll zoom in a little bit down here. So this is kind of where we're gonna be creating some of our lines. Okay, so to demonstrate this like shared construction plane, let's just draw a very simple line. We're gonna change our layer first, our current layer, to the, funny enough, the curves layer. Because remember, curves include lines. And so now that's our active layer. So now all the geometry we create will automatically be created on that layer. So we don't have to change it later. Okay, so with my perspective viewport here, I'm just gonna start drawing a line using the line command. So this is very simple, line, right? Enter or spacebar or right click. Now it'll ask me the start of a line, and you'll see under the parentheses, we actually have quite a bit of sub options. We're not gonna worry about any of those right now. We're just gonna use the default. I'm gonna click once to set my starting point, and I'm gonna make this line fairly long. And you'll notice, see in perspective, I can see this generating also. While my cursor is in the top view, I'm just gonna left click to complete that line. So that line, simple, right? It's a line, 2 points. But you'll notice that it's been flattened in perspective, right? So it's snapped and been created on this construction plane. So that construction plane is the same one as top view. They're linked in that way. However, the front and right views are different. So we can still create 2D geometry in we can create any kinds of geometry within these within the front and right viewports. But they will be projected onto a flat plane of their own. And I think this might be easiest to think about relative to the world like XYZ axes. So the front of this, the x-axis in our top view, that is represented in our front viewport. You can imagine the construction plane of the front viewport as if the x-axis was a whole plane. And I'll just demo this real quickly. Don't worry too much about what I'm doing. I'm just drawing a line starting at 0 point and kind of going on forever. We'll get into this in a second here, but maybe I should talk about this now. With this line selected, you'll notice we have one more option we didn't have with those volumes earlier. These little nodes. I'm going to click and drag this blue node, and this is going to allow me to extrude that curve in that direction. So now we have this super crazy big red plane. This is just to demonstrate that whatever I draw in front view will be projected in world view of perspective on this axis. So this sort of plane that extends infinitely in all directions in the front view, that's going to be automatically snapping to this sort of plane. That's where the construction plane of the front view lives, if that makes sense. I'm just going to delete this plane for now, but just wanted to demonstrate that. And similar in the right view, that is as if the y-axis had a plane of its own extending infinitely and was completely in all directions here. So construction planes can be very handy because they allow you to sort of break your model down into simple projections of 2D geometry, either in top view, front view, or the right view. And you can also toggle this to the left view if you want, but it's essentially the same projection, right? And they reference the world axes in this way. And this, I think, will become a little clearer as we start drawing some line. So, for instance, let's go into front view. Again, still with our perspective mode sort of enabled. I'm just going to draw the same kind of line. I can use the line command. In front viewport now, I'm just going to click sort of arbitrarily up here. And now you see in perspective, it's floating up above my x-axis. So in the front view, I'll just click to finish that line. Now, if I orbit, you can see that this has been placed on that like imaginary plane that extends up from the x-axis. So that works in these construction planes if you're not starting a line by snapping to another object. This was drawn, just kind of out in free space, so it's by default going to be projected to that sort of construction plane. However, if I was to draw a line in front view again, and instead of just kind of being out in space like where there's no other objects, if I started it instead by clicking, say, this floating cube from earlier, that's my starting point. And then if I click my end point somewhere over here, you'll notice in perspective mode, because I have planar constraint turned on, it has used the first points that I selected on that cube as a starting point and then created a line that is coplanar to that starting point. So it's no longer on this sort of default construction plane. So just so you know that construction plane is the default. If there's an object snap, in this case, one of my endpoints that is enabled by my O snaps, right? If I use that as my starting point, it's going to ignore the construction plane and use that starting point to define a different plane and create a line, in this case, on that plane, coplanar with that first point. So just keep that in mind. And now it can be also confusing if you're in front view and if you say, like, if you start at the midpoint of this cube, and then if you snap, like, say, over to the quad point of this surface, now it looks flat in front view, but you can already see in perspective that is like snapping way back from our cube midpoint to, in this case, not even the front, it's the quad of this sort of arc. So just keep in mind what you draw in a front or a right or even a plan view might be different because it's snapping to an object. If you didn't want your object snaps to be enabled, you could disable them while you're drawing, and then any 2D line that you make, I'll just do the line command again, any 2D line with my O snaps disabled will still be by default on my construction plane. You can see this one's below it, but it is still coplanar, right? I could even move it up in front view, and it's still coplanar. So that's one way you could like quickly disable any kind of funny business from snapping to different areas. You could disable your O snaps. We'll get into a little bit more advanced way of how to do that later. But that's a quick way to sort of just say, no, I just want to draw a line that's on a certain plane that's going to be defaulted to that world construction plane. Okay, cool. I think that'll be a little bit more helpful as we go on and create our landscape model when we can start defining these sort of profiles of certain geometries and we have it automatically set to that construction plane. We'll get into a little bit more depth as we go. I just wanted to point that out there. Okay, so I'm gonna delete all these lines because they're getting a little crazy. You can type in the delete command or press backspace or the delete key. Alrighty, so let's focus in top view for now because I think we're just gonna create some 2D geometry that's sort of flat to the construction plane of the world and the top because they are the same. Okay, so we've created a line. Let's create a polyline now. So I'm going to create a polyline by typing in polyline. You could also use your mouse to get that polyline tool here. Same thing. So in this case, every time I click, it's going to create a new line segment between those. And because I have ortho enabled, right, it's snapping to 90 degrees. If I wanted to disable that 90-degree snap, hold shift again, right? Now you can snap to like sort of freeform areas if you wanted to create some kind of crazy something. Let's say we wanted to sort of close this curve back to our starting point. Now, I've disabled my O snap, so it's not, if I hover my mouse, it's not snapping to that endpoint. So I'm going to re-enable my O snaps, just toggle that on. And now it'll say point, so I'm just going to click that point. And then you'll notice as soon as I go back to that starting point, it will end that polyline command. And now I should have a closed polyline. That means that there's no break. It's all joined. You can determine if it's closed or open by selecting it and going over to your Properties tab. And now you'll see type is a closed curve. We usually want to be dealing in, if we're modeling a profile of a building footprint, for example, or maybe it's a section of a wall that we're drawing, we usually want to be modeling using closed geometry, a closed curve. There's definitely a place for these open curves like we did earlier. It's just like one point to another, but that's the main difference, right? Like an open curve versus a closed curve. An open curve could be hard to spot, so sometimes using that polyline command could be that we've traced something and it looks pretty closed from afar, but if you zoom in, you'll see, oh, wait a minute, my end point and my start point are connected. Now, there's a few ways that we could go about connecting this. First, we could select this line. We could type in the command close curve. In this case, CRV is the abbreviation for curve. And we could press enter. And it'll do its best to draw a new line that connects the start and end point. But that might not be what we want. It could close it in a way, like for instance, like maybe I made a mistake, like, oh, I should have gone a little farther. So closed curve can be not always what you want. So I'm going to undo that. Another way to close this curve is you'll notice like anytime you select a curve, you have these little control points. These are those, again, like those ship control points, ship drawing control points. The same idea, right? So I could individually select one of those control points just by left clicking it. Now I could either click and drag and it'll snap to that close point. And now if I select this curve, it'll be a closed curve. So that's one way to do it. But you'll notice it's slanted, right? It's still like maybe I did want this to be a true 90 degrees all the way around. I'm going to undo that, but that is one method. The other method is to use the trim and extend commands. So if you're familiar with AutoCAD, these are similar commands in Rhino to get the most out of this, we're going to select our line. I'm first going to trim off this little extra piece that maybe I've determined that I don't need that, and this is the line that's correct. So I'm going to type in the trim. And now one thing that you'll probably want to have enabled in these options is the extend cutting lines equals yes. I think by default this is toggled to equals no. You can change those toggles to just by clicking it, but you'll want it to toggle it to yes. And that just means that this line here, this horizontal one, is going to extend in kind of an infinite plane to any object that might cross that line. Otherwise, if it's toggled to no, I'm not going to be able to trim this little segment because they don't intersect. So I find it most easiest to use the trim command with this extend cutting lines equals yes. Okay, so now my first part of the command that's being prompted, select object to trim. So I'm going to select this little tail here. Now it does matter what side of this line you choose to trim on. So I'm going to trim off this extra line. So I'm going to click on this side of the line. Now you'll notice it disappeared, the whole thing. This will happen if your line is already joined. So I'm going to undo that. I always forget about this, so this is a good example. To first sort of trim that line, you have to type in explode to be able to get its subcomponents. So I'm going to type in explode, and that will unjoin all of my polylines. So now they're just single lines. You got to kind of be careful with explode because it can be a bit unwieldy, but for this instance, it'll be just fine. Okay, so now I'm going to type in trim. Now, it will ask for the cutting objects. I'm going to use this line as my cutting object. So I'm going to say select that and then press enter. Now it will ask for the object to trim. Now this should work now. I'm going to click this little tail and there we go. See, I've trimmed off that little tail. Now I'm done with this command, so I'm just going to press enter or escape. If you've completed that command, you can usually do escape. Sometimes escape will actually cancel the command if you're halfway through it, so just be wary of escape sometimes. But trim is fine for that. If you're ever in doubt, you can just press enter and cycle through that next step. Okay, so I've trimmed my little tail off. Now I'm going to extend this line to this line using the extend command. So typing in, there we go, extend. Extend, it helps if you can type. Select the boundary object. So I'm going to select this as my boundary because I want to extend that line to that boundary. And now I'll press enter. Now the next part of this command is select curve to extend. So I'll select that end. And there you go. It's snapped and extended directly to that plane. I'll press enter to finish that command. Okay, now we've got a series of unjoined commands here, or unjoined lines. So to join these all together, I'll first select them all by clicking and dragging a big window here, left click and drag, and just make sure that window covers the whole lines. Now I'll type in the join command. That's kind of the opposite of explode. Join and explode are two halves of the same coin. So type in join. And now if all has gone well, if I select this line again, I should see it as a closed curve, right? So that's one more precise way of creating a closed curve if you have an unjoined or open curve. All right, cool. So that's all good. Now I generally do a lot of like 2D line work to create the profiles for some later 3D extrusions. So I think most of the time I either am modeling that in the top view or occasionally I'll go into like a front or a right view if it's easier to sort of create that 2D line work there. It can be a bit unwieldy, so we'll just, for now, we'll just stick to the top view. All right. One command I want to show you now that we've created some 2D shapes. We'll go back into perspective view. Double click, make that full screen. So say we wanted to, like, maybe this was our building footprint, some wild looking building. Say that's our building footprint that we want to extrude into a 3D geometry. To do that, there's a few different ways, but the most straightforward is using the extrude command. So we'll type in extrude, E-X-T-R-U-D-E, curve, extrude curve, pressing enter to activate that command. Okay, now it's prompting me to select the curves to extrude. So I'll select this one and then press enter. And then right off the bat, it's creating this volume along the z-axis. By default, it may not appear solid. So if you see in the parentheses of this command, you'll see the solid equals yes. That might be toggled to equals no by default. So in that case, you'll just be creating this sort of outer sort of shell. So if you, most of the time, you'll be creating solid objects from extrusion. So I would just say solid equals yes. And then I would also keep delete input equals no. Otherwise, that line that we're using to create this will be deleted. And that can be a little dangerous because sometimes you need to have a way back to create that extrusion once again. So I always like to keep those input objects. So make sure delete input equals no so that we save our input objects. Okay, so now you can either arbitrarily click your left mouse button and set the height for this, or you could type in a specific distance, so maybe it's 20, and then press enter. And there we go. We've created a new object. Now I'll do zoom selected again to get reoriented. There we go. The camera's getting a little weird. So yeah, and it has saved my 2D line, at least it should have. If you click near the edge of this object, you should see this little selection window pop up. Whenever you have multiple objects that are very close to each other, or perhaps they're even stacked directly on top of each other, you'll get this little selection window, and it will prompt you what you want to select. So you can either say, I want the curve extrusion, or actually I don't want to select anything. But so if you're ever like hunting for something, that's just why this thing is here, and then you can click that curve. So it's kept my curve as that extrusion object, which is great because sometimes, you know, you might want to go back and edit that later. Okay, so that's one way to quickly create a volume from a 2D line. But there's another way I'll show you here in a second. So I'm going to make a copy of this curve. Again, just using the gumball. I'm going to drag it along the y-axis. And then while I'm still dragging and holding with my left button, tapping Alt quickly to make a copy. And now I'll show you this fast way to create an extrusion using the gumball. So we kind of did a little bit of this earlier, but you see this blue node. That if you click that, either click just once and then enter a distance, you'll see it's created an extrusion. Or if I undo that, just Control Z, you can click and drag, and then whatever height that you drag that up will create an extruded object. Now, in some cases, this will be a solid object, but I do believe by default it creates this shell. And I'm going to have to hunt here for a second. Yeah. If you go to if you right-click Gumball and then go to Settings, we'll get a little bit of information about our gumball. And just looking here, then notice this on some of our Rhino 8 users. I think, yeah, I'm pretty sure that that's a new feature in Rhino 8 that automatically extrudes a solid object rather than just a shell. So if you're using the gumball in Rhino 7 to extrude this and want to create a solid object from the shell, the command cap, C-A-P, like a baseball cap, that will create a solid object from this 2D sort of thin membrane. So with the, well, I'll just type in cap without the object selected. It'll ask me what object to select, so I'll just choose the object, and then type or press enter. And then it should create this closed top and bottom solid object. Cap will work if those open areas are planar, meaning that they're flat. If it's super complicated or any up and down like non-planar open areas, cap will not work in that instance. But usually when you're extruding curves, it's already going to be a planar curve if you've drawn it on the construction plane. And so that will have no problem. Cap will have no problem creating that solid object. So that's another way to create a solid object. It truly, I think, extrude curve is a little bit more precise. So a little less steps either. So those are some ways to create some 2D lines. So you can do this with any 2D lines. Extrude curve. So you can go to town. You can even use one of our control point curves, one of these super curvilinear. And in this case, you'll notice I'm working in perspective for drawing these 2D lines because top and perspective share that construction plane. I don't have to worry about this line snapping to something else. And well, I still do, but I know that unless it is snapping, like for instance up here, unless it's snapping to a different object, it's going to create a flat plane. So I could create like a pretty weird amoeba-shaped object. And then I could also use that extrude curve command. See, it's already learned. Rhino is pretty smart. It will learn the most commonly used commands that you like to use and will prompt you for those. So be accurate with your typing because you might be setting yourself up for a command you don't want to be using right away. But yeah, same thing, extrude curve, right? And then clicking up there. So super fun way to create, either very orthogonal shapes, curvilinear shapes, all kinds of shapes. Alrighty. One other thing that we didn't really cover in our in-person workshop series is a very like basic intro to Boolean commands. So I want to show you some of those real quick. Okay, so Boolean commands, what are those? If you go over to your toolbar and if you see these two spheres that are sort of intersecting, those are that's the Boolean union tool, but if you right click and hold, you'll see underneath that there are all these other Boolean operations. And what are these? They're essentially using volumes to either unite, there's also difference, subtraction, there's intersection, which only leaves the common sort of Venn diagram that overlaps, or split, and there's a whole host of others. But the most common are going to be the Boolean union and Boolean difference. Union adds and Boolean difference subtracts. So these are ways to use volumes of closed poly surfaces to either add or subtract to other volumed objects. Okay, so what does that even mean? So say we wanted to create an object from the subtraction of a shape like this from this red shape. So first you would use the gumball to kind of line these up so that there's an intersection of some kind. And then so say like maybe I'm trying to create like a little alcove. I mean, this might be building scale, so maybe this is like an outdoor patio, for instance. I'll intersect this, and then maybe I decide this. Maybe I'm going crazy. Maybe this whole volume, like underneath this area, should be sort of carved out. So I'm going to make that kind of wildly big like that. Okay, so there's two ways we could carve this out. The Boolean difference tool from this drop-down menu. It's a little hard to get to because it's that second one. Or what I have just come to use as best practice, Boolean difference. Boolean difference. And now the first part of this command will be selecting the surfaces to subtract from. So I want to carve away from this red object. I'll press enter. Now it'll ask me, what do I want to subtract with? And then this will be my subtract with. Now you'll notice there's this one option in the parentheses, delete input equals no. By default, I believe it's toggled to equals yes. And this will delete my cyan shape altogether. Now, sometimes you don't need it, but oftentimes I will be needing to come back and use that same object to subtract with. So I'm going to keep this, I'm going to toggle it so that it's delete input equals no, because I might need this later. So I'll toggle it to no, and now I'll select the thing I'm subtracting with. So that's this teal cyan object. Now I'll press enter. Now, you'll notice not a lot has appeared to have happened, but if I move this object out of the way, you'll see that I have in fact carved out that volume from this poly surface. Pretty cool. So I'll just undo the move for now, but it's still there. There's another way you could kind of see what's going on when these things are intersecting. You can toggle your display mode to ghost it, and now you'll see this sort of like, ooh, ghosty, spooky way of looking through a model. And then you've seen that that has indeed been effective. We still have our outline, right? But this red poly surface has been carved out, right? So my workflow, my preferred workflow, is to have a separate layer that I put all of my Boolean difference geometry on, so that if I do need to like rebuild this model, I have a way back and I don't have to rebuild all these things later. So I usually have a construction geometry layer that has all my 2D lines, and then either I put the Boolean difference geometry on that construction geometry layer, or if it gets super complicated, I'll make its own Boolean difference layer and just change those objects. It's super handy workflow to always have a way back to what you're creating. All right, so Boolean difference is pretty cool. So go ahead and play around with that. Make some of your own shapes and Boolean difference things out. But as you're doing that, keep in mind there's some limitations to Boolean difference. For example, if a object is barely intersecting, or it's just intersecting a plane of one of the objects you're trying to intersect with. For example, here, I'll just move this out of the way here for a sec. Go ahead and delete some of this stuff just to clear. So what do I mean by barely intersecting? We're gonna learn our first precision movement command, which is move. So I'm gonna move this object so that it's exactly coplanar with this face. So I'm gonna type in move without anything selected. Type in move, select objects to move. Now, I've been kind of doing this just to show you those first steps of the command, but oftentimes, if you know what you want to do, you can go ahead and select that object. Like, I'm going to be moving this object, and I'm going to type in move, and it just skips that first step in the command. So it's just a little bit more efficient. So that's what I'll be doing for the next few ones. So move command. First part of that, after you've selected it, the object, the point to move from. So this is where do I want my starting point to move from to be. If my goal is to put this face exactly on the same surface as this, I'm going to use this corner point as my move from point. So I'm going to left click. And if your O snaps are not enabled, make sure they are by checking end, point, mid, intersection. All are common suspects. Make sure they're enabled and that they haven't been disabled here, right? Okay, so my O snap, I'm going to snap to that end point and left click. And now it'll ask me the point to move to. So I'm just going to find a point on this surface and on this surface edge. It's going to be right there. I'll left click, and that's completed the move command. super handy, right? This is a precise way to move things to exact locations with your OSNAPs enabled. Okay, so some of the limitations of our Boolean difference command. If I wanted to subtract like we did earlier, I'm going to type in Boolean difference with my starting object as the one that I'm wanting to subtract away from. And now it's already asking, what do I want to subtract with? So it'll be this teal one again. Now pressing enter. Now you'll notice not much has happened, like at all, like really at all. If I move this out of the way, nothing has happened. Oftentimes, Boolean difference will fail entirely if only a surface is tangentially intersecting that volume. So in other words, if these two are like, just back to back, there's nothing happening. Even if like portions of this are, then this Boolean difference operation will fail. And sometimes you'll be able to see in the command line if that has failed. So I'll type in Boolean difference again, select my subtraction object, and enter. You'll see sometimes information will pop up here. In this case, I don't think there's any intersection at all, so it's just skipping it entirely. But sometimes you'll have like very bizarre errors happen that can really just be a pain to deal with. So for example, let me try moving this to be exactly at this corner here on the inside. And you see like even the display mode is sort of freaking out. It's trying to figure out what plane to display. So it's kind of just going crazy. So let's do Boolean difference again. I'm going to subtract with the same object. Now in this case it did work. I'm a little surprised. So I'm trying to, it's always the way if you're trying to get something to break, then it ends up working. But if that does not work, you'll often see in the command line above, in this little area above the command line, this is your command history. It'll say Boolean difference failed, and oftentimes it'll display these like little exclamation points, and those are just saying these are the areas in where that it's failing. Let me see if I can get this to break. We're trying to break Rhino. Pay no attention to what I'm doing just now. We'll get to that in a second. Boolean difference. This is just to represent if you had two surfaces that had one of their lines intersecting. So let's see if we can do a Boolean difference here. Man, it's still working. Okay. Wow. Well, just keep in mind, there are some limitations to the Boolean difference command. All right, so that's how you would do a Boolean difference command to subtract away from an object. But you can also add to other objects. You can merge them using the Boolean union command. So, for example, maybe we want to merge these two shapes here. Something like this, maybe this is representing like the volume of a building, or even this could be a site wall, for instance. And we want these two objects to be treated as one object, right? So this top level Boolean command is our Boolean union. So you can go ahead and click that. And then the first part is going to be selecting the poly surfaces to union. So I'll select these both and then press enter. And now you'll see these extrusion objects have changed their sort of display mode, and they are now treated as one sort of solid object. So there you go. Boolean union is a little tricky. Both of these Boolean union and Boolean difference commands are a little tricky because they do kind of destroy that original geometry. So for instance, if I wanted to get back to my two separate objects here, there's not a very easy way to do that. You could type in explode, but I'll show you what that does here. Instead of getting back to my original geometry, it's just exploded every surface now. And so this can be a pretty unwieldy, if you're trying to move this. Oh man, see, look, now I've got all these edges and surfaces. So that's one of the limitations of Boolean union, is that there's not an easy way to go back to those prior separate objects without completely rebuilding it. And so that sort of highlights this workflow idea that I'll show you here, that I mentioned a little bit earlier. but always have a way back to create those. Since I created these objects, I'll just undo that explode. Since I created these objects just from like a freeform gumball edit, I have no way to really rebuild these unless I go back and like trace around the perimeter. And I could do that. I could use the polyline tool, and I could trace around here to get my line if I wanted to re-extrude this. Then I have this line up here. I could do the same with this. But rather than trying to rebuild something from scratch, I think it's better to be able to manipulate that source geometry in a way that's a little bit more user-friendly. So I'll just get that out of here. So that's where I really would recommend always having, in this case, we're going to create the construction geometry layer. And this will be your layer that you can put all your 2D line work on. And I like to make this a pretty obnoxious color so that it's like very noticeable. Choose whatever layer you work, make it high contrast. I like the magenta one, it's just like eye-catching. And then I'll make that my current layer, right? And then I've got my my box, my cone, all these other things. But you can name this however you want. I also like to set up an extrusion layer, extrusion geometry, and so that way I can use like the polyline tool, and this is now with my construction geometry layer active. So I can use this to my heart's content to create all kinds of objects, and maybe I got a crazy entry there or something. Who knows? I can extrude this. First, I would make my current layer the extrusion geometry layer. Oh, excuse me. I just changed that. Sorry. Undid that. With nothing selected, then you can use this pop-up menu to change your current layer without changing any objects layer. And now I could use the extrude command, right? And then put this on an extrusion layer. So you separate out your source geometry with your other geometry that your final geometry that you want to be. And then you could also come back in here and maybe you want this. Here, I'll go back to my construction geometry and use a box command and say this is like, oh, we wanted our courtyard like kind of like patio space here. This is where I could use a Boolean command to subtract from this area, Boolean difference, right? And I could go back to my extrusion geometry layer, make that current. Then I can turn off my construction geometry, and then see there I've got a final-ish product, right? But I have a way back in case I decided, oh wait, actually that courtyard shouldn't be there. It should be somewhere else. That way you can delete that geometry, or maybe you realize like, oh wow, yeah, this whole shape needs to be different. Like it needs to be like a different shape entirely. And then you can extrude that up, and then maybe actually this needs to be a longer geometry for my courtyard. Maybe it's shared throughout those spaces. It's Boolean difference, right? Bring that up real quick. And then you can go and toggle off your construction geometry layer. So it's just a fast way so that you can go back and edit those layers. Okay, cool. So those are Boolean union, Boolean difference. There's also Boolean split, intersection. I honestly just use Boolean union and Boolean difference primarily, like 99% of the time. So those are a quick introduction to Boolean commands and how you'd go about using those to subtract or add to existing geometry that are volumes. Alrighty, I believe that's going to wrap up this second part of our intro to Rhino on how to create some basic line work and then use that line work either in like a very orthogonal way or in a very like free form way to extrude volumes. how to also use basic Boolean operations to subtract from those volumes, right? So creating both either subtractions or unifications of those geometry. So go ahead and play around with that. Make some go ahead and make some like crazy objects. You can use cones and spheres to subtract from things, right? Like you could make a whole thing of Swiss cheese just by going through and subtracting a whole bunch of geometry from one. Go ahead and experiment with the move command, using that to snap to different locations of objects, and then maybe having a little bit more fun with the gumball. Use the gumball to create copies of geometry. So like maybe you were making Swiss cheese. You can also scale things kind of crazy. Maybe there's like a giant bubble that goes through this cheese. Maybe you've got like tons of different like little bubbles of Swiss cheese. I don't know why my mind is on Swiss cheese. Getting close to dinner, I guess. So then you could have some fun with it. Go ahead and experiment. Boolean difference. Just make some crazy fun shapes. And then if I was to toggle off my sphere layer, oh, there you go. There's some Swiss cheese. So make some abstract forms. Use the move tool to kind of place those forms precisely. Use gumball to scale, copy, rotate, move about. Use your lines to create construction geometry to then extrude. And be a little bit thorough with your layer management. I think the earlier the better for that. And go have some fun. So until next time, happy modeling.